right, we're ready to finish week 7. Amir, is that you? Wow. Wow. Thank you. I just wanted to thank you. Let's get back. All right, we're going to finish week 7. Does anybody know what's happening in 2.5 days? 2.5 days?
Spring break.
Spring break, is that true? Wow. That's 2.5 days. Is that 2.5 days? Not weeks, days. But then 2.5 days and 2 weeks from now is what?
Exam or quiz.
That's right. There it is. On March 9th is your quiz. 2 weeks and 2.5 days from right now is your quiz 2, which is worth more than quiz 1. I believe it's like 20% of your grade, so it's a big deal. 1/5 of your grade. So be prepared. Same rules as quiz 1, nothing changes. Anything posted on Canvas is up for grabs. Just have it downloaded, ready to go wherever you happen to be. You know there'll be seat assignments. Everything's the same. No changes. All right, so did we talk about this? Just checking. Does anybody know if you would have lost or made money if you had it in the market today at this time, right now, at 11, whatever it is? Would you have made or lost money right now for the day? No one knows. You have to create that habit to look, because you're not too many years away where you have to look if you care about your retirement. Loss. Loss it is, probably 1% last I looked. Is it more than 1% now? 1.4% loss just in an hour and a half. All right, let's review a little bit. Today, by the way, we're going to be talking about conditional probability, and here's the formula for conditional probability. The key is understanding what given means. That, whatever event that is, these letters represent events. There's A event and a B event. And the event can be anything, which we'll talk about in a minute, but the B, when you have that straight line, this is a straight line here, this stands for conditional probability, and that B is the given. Here is the multiplication rule, which includes conditional probability, but here's where a lot of students get confused. This, by the way, sometimes it's called multiplication rule, sometimes it's called multiplication law, but don't get it confused with this multiplication rule or law for independent events. This is very different. These two are not the same. So let me repeat this, because for sure you have a question in your future about independent events. Hint, hint. So this formula is the multiplication rule or law, but this one is the multiplication rule or law for independent events. So that's the difference between them. These are also little rules for independent events. So you got 2 of them here for independent events, and this third one for independent events here. These will all make sense. Right now, A and B represent events. Now, I'm going back to last week to make sure we can understand events. I want to talk about some of the events here. In this picture here, that first number on the left of the parentheses where the pointer's going up and down, that is the possible result of the first investment of 2 investments. Remember, there was Markley Oil, Collins Mining. There were 4 possibilities on the first investment: make 10,000, make 5,000, break even, or lose 20,000. The second investment, Collins Mining, there were 2 possible outcomes: make 8,000 or lose 2,000. So we put those 2 events together, and here's the 8 possible outcomes. Now, an event would be something like this. Me saying to you, how many of these 8 would you use if I said, find the probability of the event, Markley Oil loses money? How many of those would you use to find the probability of that event?
Which one was Markley Oil?
Markley Oil is the first number on the left of each parenthesis. Markley Oil loses money.
It's 2.
2 of them. Only two. The last two, the bottom two, minus 20,000, minus 20,000, those bottom two. The ones above it have marketing oil breaking even. That's not losing money, so you gotta think of the words. But that was an example of an event. There's so many different events I could describe right now. I just want you to understand event. I'm gonna do one more though. I wanna make sure you're getting it. How many out of those 8 would you use if you had to find the probability of the event Collins Mining loses money?
4.
4. Anywhere the -2 is. The event was Collins Mining loses money. The outcomes that you used to find the probability of that event were those 4, number 2, number 4, number 6, and number 8, wherever the -2 was, and then you would take those probabilities from there. So you're getting it now, you understand events. Now, we already last week learned about the event. This time I'm going to say, how many of these outcomes would you use if the event is Markley Oil makes a gain? How many outcomes would you use?
6.
No.
4.
4.
4. Not Markley Oil breaks even. That you can't use those. Markley Oil makes a gain, which is the 10,000, the 10,000, the 5,000, the 5,000, those top 4. So you're getting it. If you add the probabilities of those top 4, that'd be 0.20, what is that? 20%, 8%, 16%, 26% equals 70%. That's the probability Markley makes a gain. There it is. I added those 4 up. Next event. Collins Mining makes a gain. How many out of those 8 are you going to use for that one? 4 it is. That first one where the 8 is on the right-hand side, so there's 20%. That third one where the 8's on the right side, there's 16%, so that comes to 36. The 5th one down is 10%, and the 7th one down is 2%. That adds up to 48%. We just talked about these 2 events, but before I wrote these, before I pointed these out, we talked about the event of Markley Oil losing money. We talked about the event of Collins money. So when you're reading a problem, the event could be anything that's described that you would use this data to calculate that probability. So there's an event, there's an event. Now, I'm going to go forward a little. We also learned, and by the way, there's the calculations. We already did this last week, 70%. There's the 48%. Now, we also learned a complement of an event, a union of 2 events, intersection of 2 events. And I said, write down these key words for union of 2 events. What was the key word? Or. Intersection of 2 events, key word. And, mean both at the same time. All right. So here is the union 2 events, but I want to talk about the intersection of 2 events. Now I went ahead and made a screenshot of this so we can always go back and look at these 8 outcomes. The question says, using these 8 outcomes, how many of them would you use to calculate the probability that Markley Oil made a gain and Collins Mining made a gain? What word did I use in the middle? And, which means intersection, which means they both have to be able to be making a gain at the same time. Not one or the other, at the same time. How many of those is that happening? 2. The first one and the third one. You add those up, 20% plus 16%, that's the intersection. Markley gain, intersection, Collins gain. And, A-N-D, right there. That's what we just found. Now, here's the multiplication rule. The multiplication rule says if you know sorry. Jumped ahead of myself. Again, forget that for a second. Jumped ahead of myself. All right, now, we got to find the probability event and the probability of the other event on this, right here. Whoop. Right here. Here we go. There's all kinds of events you're looking at there. On the left side is how the questions were answered on these surveys, satisfied with the experience, or did you receive your products on time for the holidays? There's yes, there's no. So if I said to you, how many of these numbers, you see 4 of them there, how many would you use if I said the event, find the probability of the event that customer said they did not receive it on time. How many numbers would you use to calculate that probability? Two of them. What's one of them? 2.2 and 9.53. You're getting it. You got it. All right, so what I want to do, though, is I want to make the probability that they did, yes, received on time. Received on time. Here we go. What's the probability of this event that they received their products on time? They said yes to it. What numbers would I add up?
79.8.
79.8. Whoop, whoop, forget her. 79.8 plus 8.47. 8.47. So I'm gonna make it into a decimal. 0.8827. This is 0.8827. You got it. Now I want to do a probability of another event that they said yes, they were satisfied with the experience. Okay, let me get my calculator. What two numbers would I use? I don't even need a calculator for this one. What two numbers would I use?
79.8 and 2.2.
79.8 and
2.2.
2.2. 79, 80, 81. The 8 and the 2 makes 82%. Is that correct? 0.82?
Yeah.
0.82. There it is. All right. Now I want to know the probability of the intersection. This would be the probability of yes on time, intersection of yes satisfied with the experience.
79.8.
Yeah, it's right there. Exactly. Equals 0.798. 79.8%, but I'm putting them all in decimals to stay consistent. All right? So there we go. Now, oh, we did the additional one. Here we go. Here is the conditional probability. And the conditional probability says, given B, the letter on the right-hand side of that straight line is the given event. Given whatever that event is, the given event's going to be the B automatically when you're reading the problem. You know that's what you start looking for. What probabilities add up to that event, and you put it in the denominator. Okay, but with a conditional probability, you can only decide what goes in the numerator based on what you put in that denominator. You cannot use anything that didn't fit into that denominator. So, are you ready? Let's go back to this. Here's the 8 outcomes. Here they are. We're going to turn it into a conditional probability question. Matter of fact, okay, here we go. Given, whoops, hang on. I forgot which one's the given. Anybody see where that piece of paper just went? All of my notes are gone. Did it fly somewhere? Did I hand it back? All right, given, make it up on the fly here. Oh. Markley Oil. Given Markley Oil made a profit, what's the probability Collins Mining will make a profit? Now, stop right there. Focus on the part that says given, or it might say, assume Markley Oil made a profit. It will say something that says, trying to tell you this is a conditional probability. And once you recognize the conditional probability, you say, okay, I'm going to stare at that condition first. There's my denominator. So here I'm going to say it again. Given that Markley Oil made a profit, what's the probability that Collins Mining will make a profit? Focus on the given. Markley Oil makes a profit. You already told me how many of these outcomes would I use that describe Markley Oil made a profit. The left-hand number. 4, the top 4, correct?
Yeah.
So the denominator, this is it right here. Given Markley made a gain, so our denominator is 0.70. I'm adding those top 4, which we did already right here. The probability of Markley making a gain, we added those top 4, and it equals 70%. Now, you can only look at those top 4 outcomes, because those are what are in the denominator. You must ignore the bottom 4, because they're not part of the denominator. And then you answer the question, what's the probability Collins Mining will make a gain? how many of those top 4 that are part of the denominator fit that Collins Mining made a gain also?
2.
2 of them. And that's the key to understanding this. It will be the intersection of the 2 events. Whatever event is that's given, the other event has to come out of it, so it ends up always being where the 2 events cross, where they intersect. And the 2 that you guys are telling me, the only 2 we can use out of those top 4 are the first one and the third one, correct? That's the intersection, which happened to be, I think we did it already, right
36.
here. So the numerator is 0.36, the denominator is 0.70. That's how you calculate a conditional probability. You read it, you figure out which of the 2 events is the given, you put that into the denominator, and you say, only those numbers I use for that denominator, can I figure out which ones to use for the numerator? What the question is really asking for, the probability Collins Mining made a profit. Get it? So what does this equal? Hang on, we got it right here. Let me get back to this. So, given Markley Oil's profitable, the denominator was 0.70. What's the probability Collins Mining will be profitable? The numerator is, you can only pick out of those 4, so it would be where the intersection is, where they're both profitable, which were the 2 of them, which equals 36. So the probability of this conditional probability is 0.5143. Okay, now I want to write this in letters. I'm going to put this in letters. We made Markley Oil the B. So this is the probability of the conditional outcome. Whatever the given is, has to be on the right-hand side when you write a conditional probability equation like this. We just found the probability of given B, what is A? That's the probability we just found there. And up here it says B is the given, Markley gain, A was Collins gain out of that Markley gain. All right, let's do another one now. Now, you know what? I'm going to jump around and I want to see if you guys forget this before we do the other one. I'm going to maybe ask for help. So let's go back to the instructions. We have 2 assignments due Thursday, and then you're on spring break after that class. But you're handing them in 2 days. There's a written assignment and an Excel assignment. Let me show you the written, and this will give me a chance to give you a big hint. Do you guys still have your notes from Thursday of last week somewhere in your possession? Because this homework is really all about what we learned on Thursday, the first couple of problems, but even more so, your in-class assignment today is all about those notes you took on Thursday. So to be prepared for that, have those ready to go. And here you have 1, 2, 3, 4. Let me read number 1, and then I'm going to read number 3, so you can see the difference between a question and a conditional question. One says, see, I'm hiding the numbers right now because I'm not doing your homework for you. I just want you to recognize a regular question compared to a conditional question. That's all. We're not going to solve it. This is your homework. What's the probability that a randomly selected worker has answered that they have fallen asleep on the job? So that's just a regular question. You're using all the data. You're just counting those. You're saying, okay, what numbers are those that said they fell asleep on the job divided by all of those who answered the survey. That's a non-conditional probability question. There's no condition there. But look at number 3. If given a randomly selected worker is an IT professional, comma, that is a condition right there. It's saying you're only going to look at the IT professionals given. It's like hypothetically, let's say, hey, we already know it's an IT professional. We separated them or something like that. That's what the given's trying to get you to see. So it says, given a randomly selected worker is an IT professional, what's the probability that he or she has fallen asleep at work? That says, when you go to figure out which fallen asleep numbers you're going to use, it can only come from those that are already IT professionals, because that was the given. All right. Also part of your homework, there are these Excel problems. Oops, hang on. Boom, there we are. You have 1, 2, 3, 4. The top 2 are related to this up above, and these bottom 2 are related up above. But here's your big hint for this. You're either using the Excel expression for combination or the Excel equation expression function for permutation, either combination or permutation is used here. You have to read them to decide which is being used. Does anybody remember the key words I said to look for to decide which one you should use? I heard it back here, say it again. Order matters. Whether order matters or not, that's how you make the decision. Let's talk about these right now. Here's an example of combination. Let's say we have 8 different possible items here. It's how many different ways can we select 2 out of those 8. And it doesn't look like there's anything about order mattering, right? So this is how we know it's a combination, not a permutation. If it's a permutation, it would probably say you're selecting 2 items out of 8 and the order of selection matters. Or it will say, and the order is important, or something about the order. And so the Excel function is equals, COMBIN, parenthesis, the first number is always the bigger number, unless they're the same number. But if they're not the same number, the bigger number is how many you're selecting out of. And the statement said there's 8 we can select from. Comma, the second number is how many you can select. How many you're being told to select out of those 8, which was 2. So the right-hand number is how many you're selecting. So in this case, there's 28 different ways to select 2 out of 8. Now, permutation. Calculate the number of ways of selecting 2 items out of 8 possible items, and order matters. That's how you recognize it's permutation, and order matters. So, equals PERMUT, parenthesis, 8, comma, 2. How many you can select from, how many are you selecting using permutation, because order matters. If permutations are almost always bigger than combinations, or they're the same, but they'll never be smaller. You can't have less permutations than you do combinations. So if for some reason you got a smaller number there, you probably made a mistake. But you got to recognize it's a permutation. Can everybody do those 4 problems from the Excel portion of the homework? Because you only have to decide which ones of these 2 you're going to use. You're using these 2 on all 4 of those, one of these 2. Everybody okay with that? Everybody got it? Is it too easy? Should have made it harder? Is that what you're saying? Stop. Man, that's almost too easy. Okay, we're going back. Here we go. Assume that a customer responded, they're satisfied with the experience. What's the probability that they also said the package arrived on time? You want me to repeat that?
Yes.
You ready? Assume they responded, they satisfied with the experience. What's the probability that they also received the package on time? Okay, hit me with my denominator, because you've got to take that. Go with the denominator first. What numbers would you use to fulfill it? Let me first of all, I got to remember what the denominator was. The given was satisfied with the experience. That was the given. It said assume that the responder was satisfied with the experience. So give me the numbers.
79.8.
79.8 plus?
2.3.
Plus 2.2, is that what it said?
2.2.
2.2, which we did this already, and we got 82%, 0.82, which is what these add up to, so I'm gonna put 0.82. There's our denominator. Now those 2 numbers you decide to use are the only 2 numbers, that 79.8 and that 2.2 are the only 2 numbers you can use to determine what the numerator is. You cannot look at those other 2 numbers, because that is a conditional probability. It said assume or given or whatever the word is, that they already responded, they're satisfied with the experience. Then it says find the probability that they said yes, they did receive it on time. What's in the numerator?
79.8.
79.8. There's only one number of these 2 that said they received it on time. The yes for the 79.8, not the no where the 2.2 is. We can't use that 8.47. That wasn't part of the condition. It's not part of the satisfied with the experience. We got to stick with the ones we use. So here we go. Conditional probability here. Hang on. Don't look at those yet. We're not ready for those. Hang on. There we go. 79.8. 79.8 divided by 0.82, or just 82, excuse me, I did them as integers. So this is 0.97, we're going 4 digits, 3, what? 2. Got to round, because the next one after that says 7, right? So 0.9732 is that conditional probability. Let me show you what this is. This is a probability. We went ahead and made satisfy the experience the given, so that's your B. So A, B. Same way to write it as we did there. It's just a matter of understanding the B is the activity, or I'm sorry, the event that is the given. That's the condition. And you can only look at the ones that meet that condition. Okay, so now let's see. Let me go now to the multiplication rule. There it is. We're going to start up here. We had given Markley's gain, that was our 70%. What's the probability of Collins Mining then making a gain? There's the intersection of the two right there. This says if you take that conditional probability we just did right there, that given Markley Oil made a gain, what's the probability of Collins Mining making a gain? That right there, this ended up being 0.5143. There's that conditional probability. If you multiply it times the probability of B, what was B? Markley Oil making a gain. The probability of Markley Oil making a gain? 0.70. So if we multiply 0.70 times 0.5143, it will equal the intersection of these two, which happens to be right there. Right there. Let's see if it's correct. I think I made a mistake. Let me stare at it for a minute. I don't know. Anybody already tell me? Did it work? 70 times, I should be 0.7, excuse me. 51, I'm turning it into percentages, that's what I did that one. Okay, 43 equals, oh darn it, I multiplied. 0.7 times 0.5143 equals, there it is, 0.36. Look at what the intersection is, 0.36. That's the multiplication rule. Don't mix it up with the multiplication rule of, here's the multiplication rule again, there it is. It says, says the conditional probability of Markley Oil, given Markley Oil's profitable, Collins Mining's profitable is 0.5143. If you multiply that times the probability of Markley Oil, 0.70, it will equal the intersection, 0.36, which we did the intersection back here. Where's the intersection? Right. There's the intersection of two events, 0.36, the same answer we got. Okay, let's do the multiplication rule on this one now, right here. I'm going to put the numbers underneath here. It says if we can take this conditional probability, 0.9732, so I'll put it right here, 0.9732. It says that if we can multiply it times the probability of B, what was B here? Satisfied with the experience. The probability, yes, satisfied with the experience, 0.82. So here we go, 0.82. If I multiply those two numbers, it should equal, and there's the top one, the bottom one now, this should equal 0.798 if we did this right. That's the multiplication rule. So here we go. I'm going to take 0.82, 0.82 times the conditional probability of 0.9732. 0.9732, and it should equal the intersection of 0.798, 0.798 on the nose, almost on the nose, 0.7, oh my God, 98. There it is, there it is. So you've now seen how to calculate conditional probabilities twice. Once using Markley Oil and Collins Mining, and then we did it again using this survey of people receiving their packages on time, and people saying yes, they were satisfied with the buying experience. Then we went ahead and demonstrated the multiplication rule twice, using the conditional probability with the Markley Oil and Collins Mining, using the conditional probability of receiving it on time and being satisfied with the experience, proving this multiplication rule worked both times. Do not, again, I know I've said this 3 times, do not mix up the multiplication rule, law, sometimes called law, sometimes called rule, with this one. Multiplication rule, law for independent events. These are not the same at all. So this has all been about conditional probabilities. And that's the end of conditional probabilities. It's just a matter of recognizing them, realizing how to calculate it. What goes in the denominator, what goes in the numerator. Now we're going to independent events. This, for some people, I've been told this is the hardest part of the semester. Independent events. Because it's how do you prove whether 2 events are independent of each other or not. That's the key to this part of the lecture. How to prove whether they're independent of each other or not. Now, like I said, we can look at some data and there could be all kinds of events. It could be Markley Oil did make a gain. Markley Oil has a loss. Markley Oil breaks even. Collins Mining makes a gain. Collins Mining has a loss. The event could be anything. So you gotta realize the event changes depending on the story when you're reading the problem. What we're gonna do, here we go. There's our multiplication law, there it is right here. 70% times 0.5143 equals 36%. There it is, in case you want to review down there. Okay, independent events. To determine whether 2 events are independent of each other, is A independent of B or vice versa? You either have to say, let's find the conditional probability of B sub A, compare it to A, and if they're equal to each other, they're independent. Or, look at the right-hand side. The given could be A. The conditional given could be the A. The B could be the probability on top. And if it ends up being equal to just the probability of B alone, that proves they're independent. So there's 2 different ways there, and we're not done. This is the easiest way, in my opinion, of proving whether 2 events are independent of each other or not. And that's saying the probability of one event times the probability of another event. If they happen to equal the intersection, you have independent events. And this one's easier because it doesn't include a conditional probability involved in the proof. The extra step you'd have to take to find that conditional probabilities sometimes takes a lot longer than just finding the probability of A or the probability of B and the intersection. So I want to talk about this. Probability of A times the probability of B equals the intersection. I'm going to use the events we have right here. Here they are right there. I'm going to use those right there. I'm bringing the 8. I'm going to pretend we don't see what we calculated. We don't see them, but we see this calculation, but we don't see the events. Here's all 8 outcomes again. And I say to you, let's make event this B, A. Let's make event A, Collins Mining makes a gain. Now we're going to look up here, event Collins Mining makes a gain. You have 8 outcomes. How many are you picking out of those 8 to calculate the probability of Collins Mining making a gain? How many? 4 of them. The first one, the third one, the 5th one, the 7th one. We added them up already and got 48%. So there's that one. We're going to call this A, probability A, 0.48. There it is. We're going to call B, Collins Mining makes a gain. How many out of those 8 represents Collins Mining making a gain? How many? 4. The top 4, because Collins Mining was the first number. 10,000, 10,000, 5,000, 5,000. We add up the top 4, 20%, 8%, 16, 26, equals 70%. There's the event, event B. There you go. Now, when I multiply these 2, if they end up equaling the intersection, which pretend we don't know the intersection, even though it's right there, pretend we don't know it, the intersection would be that both Collins Mining, there's a certain amount of incomes or outcomes, where both Collins Mining and Markley Oil are both making a gain. The left-hand number and the right-hand number are both a gain. How many out of the 8 represent that intersection? 2 of them. The first one and the third one. 20 plus 16 is 36%. true or false. If what I just wrote is true, these are independent events. True, independent events. If this is not true, this is false, they are not independent events. That's how you prove it. You find the probability of one event, find the probability of the other, find the probability of the intersection, and then see if they equal each other or not. I know you guys know already because I took my time there, but I'm going to calculate. One event is 0.70 times the other event, 0.48.
I got 336.
Hang on. What?
I got 0.336.
That's right. These really end up equaling 0.336.
Which is false.
They're not independent. Not independent. Even though that was close, 0.33 is close to 0.36. Believe me, when you multiply, it will be the same number. That's how you know they're independent events. All right, let's keep going. We're going to look at the other way. Go back to this one. What we got here? Oh, here we go, right here. The probability of Markley oil, 70%. The probability of Collins mining, 48%. The probability of the intersection, 36%. We take 70% times 48%. Look, it doesn't equal 36%. It equals 34%. What'd you say? 0.33 something. I didn't even write it down. What was it? 0.33?
0.336.
6. So that's why it's 34. Rounded to 34 here. 0.34 rounding to 34%. It's not equal to 36%. Hence, these two events are not independent. Now, that is the easiest way to determine if they're independent or not, but I do want to tell you there's these two other ways here. Comparing the conditional probability. What most students make the mistake of if they decide to try this route is comparing the conditional probability, let's say A sub B given B then A, the left-hand one, accidentally compares it to the probability of B. When you shouldn't be. You should be comparing it to the probability of A, because A is the one you're finding the probability of. B was the given. The one on the right, A is the given. B's being asked the probability of. You compare that to B, but the most common mistake here is comparing it to A on a quiz. That's why I say this one is the easiest of the three. There's no conditional probability involved, and so making the error, the common error that are on the other two, is far less likely if you go this route. But it's up to you. And so what I did is I took this and I showed all three different ways on this posted. Here's all three of them. So I'm gonna try, so we can see all the numbers here. Received products on time. Here's the yeses. Satisfied with the experience. There's the yeses across there. I'm going to call A satisfied with the experience. So all those who said yes, satisfied with the experience, the probability of A, 82%. Look at this. We did this right here. Yes, satisfied with experience probability, 82%. Next, probability of B. Yes, received the products on time. We would add 79.8 and 8.47. And we get 88.27. There it is. 0.8827. There's the received on time. Satisfied. Here's our two individuals. Which one did we make A? So this is going to be A right here. P sub A. And this one is P sub B. Okay? P sub A, P sub B. Now, the conditional probability. This one right here says, given A. What's A? Given their satisfied experience. That would be right here. Given these two, so you add those two up, and you get 82%. What's the probability of B? Yes, they received it on time, but we can only look at these two. Yes, they received it on time, it's right there. So 79.8 divided by those two added together, come to 0.9731. Oh, 317. I didn't see the 7. There it is right there. This is exactly what we did. There's the same conditional probability I just showed you up there, right there. I flipped it. Let's do the other conditional probability. Let's say given B, that they received it on time. So now received it on time, we would add 79.8 and 8.47 as our denominator. And only out of these two we can pick, yes, they were satisfied with the experience. So out of these two, that would be that one right there, 79.8. So 79.8 divided by these two here is 90.40. So now we have this and this. I want you to look at the formula again. All right, I want you to look at the formula. Just, whoop, hang on. There. We're gonna try this one. A given B, but we have to compare it to the probability of A. All right, I think that's the first one we're doing. Let's take a look. Here it is, AB compared to A. Here's the AB right here. Given B, yes, they received the approximate time. What's the probability of A satisfying the experience? We did that and we got 90.4044. There's that one. Does it equal the probability of A, which is right up here, 82%? Yes, satisfy the experience. 90.404 does not equal 82%, so these two events are not independent. There's one way to prove it. Now, look at the second way to prove it. We're gonna flip them. Given A, the probability of B, which we did right here, given A, yes, they're satisfied with the experience. What's the probability of B received in time? So that's why the numerator is 79.8. We got 97.317 percentage. Because B's on top here, we have to compare it to the probability of B. Yes, received products on time. Not 97.317% does not equal 88.27%. So these two events are not independent. Same thing, same result as the flipped. No matter which one of these three ways we do this, we're gonna get the same result. They're not independent, but on the quiz or final exam, you gotta show the work proving they are or not independent. So you gotta give that proof, then tell me, are they independent or not? And now here's the way we did do it on the board here, using the multiplication rule. Does the intersection equal the two of them being multiplied? So the intersection of them is 79.8. We take the probability of A, which is 82%, times the probability of B, which is 88.27%, and we end up getting 79.8 does not equal 72.3814. Because those two are not equal, using the multiplication rule, they're not independent. The same result we got using the first way and the second way, but this is crucial. If you find one of these three ways easier than the others, when you're asked this question on the final exam or the quiz, you decide which one you want to use. You only have to give me one proof. You don't have to show me all three of these. Whichever one you find easier is the one you should use on that quiz or the final exam. You have this in your future. I left it off the homework to give you a break, but it is coming. So this one that's posted, this example, would be the perfect thing to have on your computer while you're taking the quiz, just in case it's on the quiz. And if it's not on the quiz, then you know it's on the final. So we'll have it ready for them. Any questions on proving whether two events are independent or not? Seriously? What are we doing? How are we doing on time? What? We're early.